Hello, welcome to lesson 10 on the topic time and work. If you remember, so far we have been discussing the problems of individual efficiency, whether it may be a case of alternate work or negative efficiencies, but people have always been contributing as individuals. Now we'll go to the second part of our discussion on time and work, which is the problems on group efficiencies. Alright, so we are going to begin our discussion on the problems of group efficiency. Alright, now the problems of group efficiency can be divided into 4 different types. So let me first begin by sharing type 1. Alright, the first type of question. 20 men working for 6 hours every day can complete a work in say 40 days. 20 men working for 6 hours every day can complete a task in 40 days. Then the question is, in how many days working for 8 hours every day can 32 men finish the same task? Alright, so this is the first type of question in group efficiency. If you remember, we have all done such questions in school, but there the objective of the teacher was also to tell us about the relationship between men, days, the total work and so on. So if you remember, there used to be arrows in our textbook. More men would mean less days for the same work. More men would also mean more work, right? More hours would mean more work, which is absolutely logical. But here our objective is to do this problem as quickly and as easily as possible. Now you have to understand a very simple aspect. The total work done by 20 men working for 6 hours in 40 days is same as the total work done by 32 men working for 8 hours in say X days. So the total work is the same, and therefore if the total work is the same, I can say 20 men working for 6 hours in 40 days, the same work, right? The same work. So what will we do? Equal to the same work has to be completed by 32 men in 8 hours. The question is how many days? Very simple. Okay. Now from here what we need to do? We need to only solve. So 8 5 times 40, 4 5 times 20, 4 8 times 32, 2 3 times 6, 2 4 times 8, and therefore x will be equal to 75 by 4 days. 75 by 4, as you would know, can also be written as 18 by 4 days. So this is the first type of question. Alright. Now what you need to understand, very simple, but what you need to understand, what all will be multiplied on the left hand side? Number of men, number of hours, number of days, and sometimes the efficiency also. So we'll take another example. So men, let me write down here, men into hours into days into efficiency. This will always be equal to the total work. Alright. So this is the first type of question where group efficiency is involved. So if you see this example, there is no A, there is no B, there is no pipe, there is no leak, there are no individuals. We are talking about groups of people working together, and that is why this is called as a group efficiency problem. Now let me take another example of type 1. So we'll take another example of type 1. just to make all of us comfortable. All right. So another example. What is the question? 15 men working for 9 hours every day at an efficiency of say eta. This is the people from sciences background, you would know that efficiency is represented in terms of this Greek alphabet called eta. So 15 men, 9 hours every day, efficiency of eta, they can complete a task in 12 days. They can complete a task in 12 days. Alright. So what is the question? In how many days can 36 men working for 5 hours at an efficiency of 3/2 eta, how many days? Now we'll add one interesting component, right? We'll add one interesting component. What is that component? Complete a task which is 25% more than the first task. All right. Complete a task which is 25% more than the first task. Now suddenly, as a student, if I am not conceptually clear, I suddenly find this question difficult. Why? Because so far I have been used to the aspect that the total work done will always be equal, and suddenly the question says that the second task is 25% more than the first. How do we proceed? Please look at this solution. It is very simple, but how will we proceed? Alright, 15 men working for 9 hours. The efficiency also gets multiplied, eta. How many days? 12 days. Let this work done be W. Alright, let this work done be W. So let me put 1 here. What is the second case? 36 men. 5 hours. What is the efficiency? 3/4 of eta. What is the number of days? I don't know. And what is the total work done? It will be 1.25 of W. Fairly simple, fairly alright. The second task is 25% more than the first. So remember the multiplication factor. So 1.25 times of W. Right? From here, if you have understood by now, and allow me to take out this particular part because we have already written the data. Okay, we already have the data. So this is W, this is 1.25 W. From here you have got two choices. What are those two choices? The first choice is you can take the value of W from equation 1 and put it into equation 2. First way. Or what is the second way? The second way is divide 2 by 1. Alright, fairly okay. Divide 2 by 1. So what will we have? 36 into 5 into 3/4 into x, right? So divided by it is 15 into 9 into eta. So this will also be eta into 12. This is equal to 1.25 W upon W. Correct? Not very difficult. From here, what do we have? You can simply solve this. So therefore, 36 into 5 into 3 into x upon 15 into 9 into 4 into 12 is 125 by 100. Let's quickly do this. This is 25 5 times. This is 25 4 times. 4 and 4 gets cancelled. 5 3 times 15. 3 and 3 gets cancelled. 9 4 times 36. 4 3 times 12. Everything is getting cancelled. And finally, therefore, the value of x is 15 days. Alright. So it is not necessary that x has to be an integer. In the last example, type 1, x was not an integer, it was a fraction. Remember, 18 3/4. But in this example, everything got cancelled, and therefore finally we got the value of x as 15 days. Alright. So this was the first type of question. This was type 1. as far as group efficiency problems are concerned. All right. Now let me introduce the second type to you. Let me introduce type 2. All right. So what is type 2? Type 2 is like this. A camp had food for 200 children for 60 days. All right. Please listen to the question carefully. A camp had food for 200 children for 60 days. After 40 days, 40 children decided to leave. Okay, 40 children decided to leave. What is the total time for which the food will last? What is the total time for which the food will last? All right. Now, exactly like type 1, exactly similar to type 1. The only difference is this question has to be started after 40 days. So if as a student you have understood this part, then everything is perfectly fine. All right. So let me repeat. 40 days have already passed. So what will logic say here? Logic will say if 40 days have passed, yes, they would have also eaten food for 40 days. So where should the question start from? The question should start from that after 40 days the camp had food for 200 children for 20 days. I hope this is clear to all of you. After 40 days, the camp had food for 200 children for 20 days. And at this stage, 40 children decided to leave. Now, the same food will be consumed by 160 children. The question is, how many days? And students, once you have understood this and done this conversion, now it is very simple. How? 200 children, 20 days. The same food, 160 children, how many days? So 45 times, 44 times, 5 times. The same food will now last for 25 more days. But what is the question? The question is, what is the total time that the food will last? So 40 days, initial 40 days. The next 25 days, the food will now last for 65 days instead of the earlier plan of 60 days. Alright. So this is an example of type 2. In the subsequent lesson, we will begin by taking more examples of type 2 before we discuss the other types. Thank you.